Okay, this video will work through questions 40 to 42 in the review. So looking at the situation, we're trying to answer the question, are people who wear glasses perceived as smarter than people who don't? A study was performed to look into this phenomenon. 80 people were shown two pictures, one of a person wearing glasses and the other of a person without glasses, and were asked who looks smarter. The results show that the person wearing glasses was chosen as looking smarter in 53 out of 85 cases. To determine whether the data show strong evidence that people who wear glasses are perceived as smarter than people who don't, which formula-based methods would be appropriate? Okay, so keep in mind we need to think about what type of variables are collected here. And here for each subject, they were just asked which of the two people they thought looked smarter, as it was either the glasses or the no glasses person. So we've got one categorical variable, which means that we've got a single proportion would be our parameter of interest. And just kind of thinking about what our hypotheses would be, our null hypothesis would be that people are equally likely to pick the person with glasses or the other one. So the proportion who picked glasses would be 0.5. The alternative would be the proportion who say the person with glasses is smarter would be greater than half. Be more likely to say the person with glasses looked smarter. And so if our p-value for the test is 0.31, what does that mean? It means that we would not, well, first of all, we're interpreting it. So let's see. So the p-value, remember, is the chance of seeing our sample statistic, or more extreme, if the null hypothesis is true. So what I'm looking for in my answers here, I'm looking for two things. I'm looking for an answer that talks about the chance of seeing this sample's result, and I'm looking for something that talks about seeing that if the null hypothesis is true. So the first thing I'm going to do is scan through and look for things that talk about our sample result. Proportion of all, okay, so that one doesn't talk about the sample result. Probability that a person that doesn't talk about the sample result. Probability that of a person wearing glasses in at least 53 out of 85 cases. So okay, that one talks about the sample statistic, but it doesn't talk about the null hypothesis, so that one's out. The probability of a person wearing glasses being chosen as smarter at least 53 out of 85 times. Okay, so that one is looking promising. It's talking about our sample statistic. If both people were equally likely to be chosen as smarter. Equally likely would be chance of 0.5, so that one looks like the answer. But just to see, I'm going to read the last one. The probability of the person wearing glasses being chosen as smarter at least 53 out of 85 times, so that's our sample statistic, or more extreme, if the person wearing glasses was more likely to be chosen. More likely is the alternative, so again, this is the right one. It's always good to double check, but this is if the alternative is true, this is if the null is true. And the p-value is always measuring what is the chance I will see my sample statistic or something even more supporting the alternative if the null hypothesis is true. And then question 42, which is the last one on this set. If the p-value is 0.31, testing at the 5% level of significance, what would we conclude? So since this p-value is greater than our 5% level of significance, we would fail to reject the null hypothesis, which means that there is not strong evidence that people wearing glasses are perceived as smarter. Now, it's not correct to say that B has been shown, because we haven't shown evidence that the null hypothesis is true. Remember one more time that when we don't reject the null hypothesis, it doesn't mean that we've shown that the null hypothesis is what is true. All we've done is said that the data that we saw is not so far removed from what we'd expect to see if the null hypothesis is true that we can throw it out. It means that basically that the data that we saw are not completely inconsistent with the null hypothesis. Okay, that brings us to the end of that one. We've got one more video.